All right, so we're back and ready to dive into another one of Professor Ghosh's lectures.
This time we're looking at Lecture 4 from his 2021-2022 Renewable Energy Resources course on YouTube.
Picking up right where we left off in Lecture 3 with all that talk about nuclear power.
And still grappling with that question of what exactly renewable means.
Which Professor Ghosh dives right into head first.
Yeah, he really jumps right back into the whole nuclear thing.
With a quick recap of nuclear fission first.
You know, splitting that uranium-235 atom.
Releasing energy and neutrons and triggering that chain reaction.
And how important it is to control that chain reaction.
Otherwise.
Well, things could get out of hand pretty quickly.
That's where moderators come in, right?
Exactly. Things like water to slow down those neutrons.
So they're more likely to hit other uranium atoms and keep the reaction going.
And then you have control rods, too, which absorb excess neutrons to keep things from going too fast.
A delicate balance.
It really is.
Yeah.
But when it works, right, you get heat to produce steam and spin those turbines to generate electricity.
I'm always amazed by how we figured out how to control such a powerful reaction.
And Professor Ghosh doesn't just stop at the theory either.
He actually walks us through different types of reactors.
Like boiling water reactors, where the water acts as both the moderator and the steam source.
Clever.
And then there are pressurized water reactors with two separate water circuits.
One for the fuel and one for the steam generation, right?
Exactly. And he even touches on CANDU reactors developed up in Canada, which use heavy water as a moderator. And, you know, all of this sophisticated engineering, all these safety measures, they come at a cost, right? It's why nuclear power plants are so expensive to build.
Yeah. That makes sense.
And Professor Ghosh, he points out that, you know, in the U.S., for example, the cost of building new nuclear plants has made it really difficult to replace those older ones that are being retired.
Yeah, it's a tough situation, right?
Yeah.
Like we need reliable energy sources.
We do.
But the cost and the complexity of nuclear power, I mean, it presents some real hurdles.
For sure.
And then, of course, there's the issue of nuclear waste, right?
Right. That's always the big one, isn't it?
Yeah.
Dealing with that radioactive waste. It's
Yeah.
a major challenge. And finding those safe, long-term storage solutions, I mean, it's absolutely essential. And it's just a reminder that, you know, there's no perfect energy source. Every option, there's going to be trade-offs.
That's a good point. So, I mean, are there potentially safer or more sustainable ways to harness nuclear power?
Well, that's a great question. And Professor Ghosh, he actually explores this very question in his lectures. He talks about the development of these things called fast breeder reactors.
Fast breeder reactors. Okay.
Yeah.
What are those? What makes them different from the conventional reactors that we've been talking about?
Well, they operate on a totally different principle.
Okay.
So in a fast breeder reactor, they use liquid sodium
Okay.
instead of water to moderate the neutrons.
So you're not slowing down the neutrons in this type of reactor.
Exactly. You're letting them fly. And that's key because it allows this different kind of nuclear reaction to occur. So instead of primarily relying on uranium-235, which is that fissile isotope of uranium,
Right.
fast breeder reactors, they can also utilize uranium-238, which is far more abundant.
Okay.
But it's not directly fissile.
Got it.
But here's the thing. When those fast neutrons, they collide with the uranium-238, they actually transform it
Okay.
into plutonium-239, which is fissile, and can then be used as fuel.
Oh, wow. So it's like you're getting more out of the uranium fuel.
Exactly. It's like you're breeding more fuel than you consume, essentially.
That's really interesting. And with uranium-238 being so plentiful, I mean, fast breeder reactors could really extend our nuclear fuel resources significantly.
Oh, absolutely. And in India, they've actually already built a prototype fast breeder reactor in Tamil Nadu, so they're really kind of leading the way in this technology.
That's fascinating. I mean, it seems like India is really at the forefront of a lot of these renewable energy technologies,
Yeah.
and especially when you consider, you know, their abundant thorium reserves.
Yeah.
That's something else that Professor Ghosh really highlights as an exciting prospect, right, for nuclear power.
Yeah, thorium, it's another really interesting one.
So thorium itself isn't fissile, right?
It's not, no.
But it can be converted, right?
It can, yeah.
To uranium-233.
Exactly. So when you bombard it with neutrons,
Okay.
it undergoes this transformation.
So it's like an indirect path to nuclear power.
It is. And here's the really exciting part. India, they have vast thorium reserves. I mean, way more than their uranium reserves. So this could be huge for them.
It seems almost too good to be true. Is there a catch?
Well, there's always a catch, right?
Yeah.
Thorium-based reactors, they're still kind of in the early stages of development.
Okay.
India, they were kind of pioneers in thorium research, but they're not alone.
Okay.
China's also been making some really significant strides.
Oh, wow.
And Professor Ghosh mentions that they're getting very close to actually having a commercial thorium reactor up and running.
So there's this global race, right?
There is, yeah.
To unlock the potential of thorium.
Yeah, and it really highlights the urgency and the opportunity,
Yeah.
in finding these safer, more sustainable alternatives to traditional nuclear power.
So many different designs.
Each with their own pros and cons, of course.
But then Professor Ghosh throws us a real curveball.
This is where things start to get really interesting.
He starts talking about getting uranium from phosphate fertilizers.
It's a pretty unconventional idea.
Especially for a country like India, which doesn't have a lot of uranium reserves.
Right, and Professor Ghosh even shares some research from his own lab where they analyzed fertilizers available in India.
And
significant amounts of uranium.
So every time we fertilize our fields, we're basically kind of introducing uranium into the environment.
That's exactly right. And this is something that Professor Ghosh, he really dives into.
Okay.
He talks about how uranium contamination in groundwater, it's a known issue, right?
Yeah.
But it's often attributed to just kind of natural things, geological sources.
Yeah.
But he's suggesting that maybe these fertilizers, this widespread use of them,
Okay.
might actually be a bigger contributor than we realize.
That's concerning.
Yeah.
Okay, so give me some actual numbers here, just so I can wrap my head around the scale of this.
For sure. So the phosphate fertilizers they use in India, on average, they contain about 302 milligrams of uranium
Okay.
per kilogram of P2O5, which is that active ingredient in the fertilizer.
Okay.
But here's the thing, they use a lot of this stuff. They use 6.9 million metric tons of P2O5 every year.
So we're talking about a significant amount of uranium that's potentially like going to waste here.
Oh, yeah. We're talking over 2,088 tons of uranium. Think about that.
Wow.
That's actually more uranium than what they need for their entire nuclear power program.
That's incredible. Especially when you consider that India actually relies heavily on imported uranium.
They do, yeah.
For their nuclear power plants.
Yeah.
So I mean, if they could tap into this fertilizer source, I mean, that would be a huge deal for their energy independence, wouldn't it?
Absolutely. It would be a complete game changer for them. Makes you think, what if we could just take that uranium out before it even reaches the fields,
Yeah. Like, what if we could extract it?
Yeah.
Yeah.
That would be the ideal situation.
That would be amazing. I mean, that would be like a win-win, right?
Mm-hmm.
You get a cleaner fertilizer, and you'd have this source of fuel for nuclear reactors.
Absolutely. You hit the nail on the head. Shifting gears a bit, Professor Ghosh takes us on a journey into the future of nuclear power.
Diffusion.
The holy grail of clean energy.
Replicating the power of the sun right here on Earth.
That's the dream anyway. And it all comes down to fusing hydrogen isotopes
Deuterium and tritium.
into helium, releasing massive amounts of energy in the process.
The challenge, of course, is replicating the sun's extreme temperatures and pressure.
Which is no easy feat.
So how are scientists even trying to achieve this?
Well, Professor Ghosh explains that there are two main approaches.
Lay it on me.
First, you have magnetic confinement, which uses powerful magnets to contain superheated plasma.
Plasma.
That's just a fancy way of saying ionized gas.
Okay, got it.
So you have this superheated plasma contained by these magnets, preventing it from touching anything and cooling down.
Sounds like a delicate operation.
It is very much so. Then there's the other approach called inertial confinement.
What's that all about?
That one involves bombarding tiny pellets of frozen deuterium and tritium with high-powered lasers.
So instead of containing the plasma, you're essentially creating these miniature explosions.
Yeah, exactly, for just a fraction of a second, enough to generate those extreme temperatures and pressures needed for fusion to happen.
Wow. Both methods sound incredibly complex.
They are, but Professor Ghosh highlights all the rapid progress being made in labs all around the world.
Like he mentions the National Ignition Facility experiment in 2021.
Where they achieved a record 1.35 megajoules of energy output.
Getting closer and closer to that magic word.
Ignition.
Where the fusion reaction produces more energy than it takes to start it.
Making it self-sustaining.
That's the dream right there.
The ultimate goal of fusion research.
So it sounds like fusion has incredible potential.
It does, but there are still some hurdles to overcome, as with any groundbreaking technology.
Not quite.
Professor Ghosh points out the need for a reliable source of tritium.
One of those hydrogen isotopes we talked about earlier.
Right, and currently we produce tritium from lithium, which is facing its own supply constraints.
Oh, so another resource challenge.
It seems like there's always another challenge around the corner, but Professor Ghosh is optimistic.
He even challenges us to think about innovative ways to extract lithium from seawater.
Which could potentially address that bottleneck.
So even though fusion is still a ways off, it's exciting to see all the progress being made.
Definitely a lot to look forward to in the future of nuclear power.
And speaking of the future, in the last part of this lecture, Professor Ghosh introduces a new topic,
Bioenergy.
which he'll be exploring in more detail in Lecture 5.
But he gives us a little taste of what's to come.
Starting with the connection between bioenergy and a process we're all familiar with.
Photosynthesis.
That amazing process that plants use to convert sunlight and carbon dioxide into energy.
And Professor Ghosh really emphasizes the importance of understanding both sunlight and carbon dioxide as the key drivers of photosynthesis.
He even takes us through the basics of how that sunlight is absorbed by chlorophyll.
So those plants are like little factories churning out energy.
It's mind-blowing how efficient they are,
Well, Professor Ghosh really gets into the nitty-gritty of how that whole process works.
breaking down photosynthesis step by step.
He even talks about those thylakoid membranes.
What are those?
You know those little stacks of pancake-like structures inside the chloroplast?
Oh, right. Those are where the light-dependent reactions of photosynthesis happen.
Exactly. They're the real MVPs of the whole operation.
Splitting water molecules, releasing oxygen, and generating all those high-energy molecules like ATP and NADPH.
And it all starts with chlorophyll
That pigment that gives plants their green color.
and acts like a tiny antenna capturing sunlight.
Triggering that whole chain reaction.
And then in the stroma, you have the light-independent reactions
Where the ATP and NADPH get put to work.
to convert carbon dioxide into all sorts of organic compounds.
It's like a carefully choreographed dance.
It really is, each step perfectly synchronized with the next.
Professor Ghosh even walks us through the Calvin cycle,
That's where carbon dioxide gets fixed into organic molecules.
forming the building blocks of life.
And at the heart of it all is this amazing enzyme called rubisco.
I've heard of that one.
It's one of the most abundant proteins on Earth.
Really?
Yeah, and it plays a crucial role in capturing carbon dioxide from the atmosphere.
So a key player in the fight against climate change.
You could say that, but let's shift gears a bit and talk about the practicalities of bioenergy.
Right, because all this science is fascinating, but we need to figure out how to actually use it.
And Professor Ghosh doesn't shy away from the challenges.
He even brings up that crucial question of efficiency.
How much of that sunlight can plants actually convert into usable energy?
Remember that Jatropha example from earlier?
Less than 1% of the total solar energy hitting the plant over 6 months ends up as oil in the seeds.
Yeah, that doesn't sound very promising.
But Professor Ghosh reminds us to look beyond those simple calculations.
Because plants aren't just producing oil,
Exactly. They're also creating all that biomass in their stems and leaves and roots.
which can be used for energy too.
Absolutely. We could burn it directly, convert it to biofuels, or even use it to generate electricity.
So the efficiency picture starts to look a lot brighter when you consider the whole plant.
And there's another important factor to consider.
What's that?
Not all wavelengths of sunlight are equally useful for photosynthesis.
So plants are a bit picky about their light.
In a way, they primarily utilize the visible spectrum, but our typical measurements of solar energy often include a much broader range.
So if we focused on those wavelengths that plants actually use,
The efficiency of photosynthesis could be much higher. It's a reminder that we need to look at the whole picture.
and all the nuances of the process. Are scientists working on ways to kind of boost that efficiency?
Oh, yeah. Researchers, they're always exploring ways to enhance photosynthesis, both in natural plants and also by developing these artificial systems.
Imagine if we could like crack the code on that, right?
You'd be amazing.
And create like artificial photosynthesis that could rival the efficiency of solar panels.
Oh, that would be revolutionary. It would completely transform how we generate energy, and it would help us to address so many of the world's energy challenges.
Yeah.
And remember that idea of plants being energy concentrator?
They take diffuse sunlight and convert it into these concentrated forms of energy.
Like oils, starches, and sugars.
It's remarkable.
It really is. Nature has already solved a problem that we're still grappling with.
I have to admit, I'm pretty excited about the potential of bioenergy.
Me too. There's a lot to be optimistic about.
But I'm also curious to learn more about the specific technologies and approaches being developed.
Well, you're in luck because in our next deep dive, we'll be unpacking all of that.
We'll be exploring the diverse applications of bioenergy and the challenges and opportunities that lie ahead.
As we work towards a more sustainable energy future.
Sounds like it's going to be another fascinating deep dive.
I can't wait.
It's fascinating how nature always seems to be one step ahead.
Professor Ghosh has given us so much to think about when it comes to bioenergy.
He sure has.
It's clear that there's a lot more to learn about this fascinating field.
And we'll be diving deeper into that in our next deep dive.
From the fundamental principles of renewable energy
To the intricate workings of nuclear fission and photosynthesis,
we have explored the power of scientific discovery
the ethical dilemmas we face.
and the importance of critical thinking as we navigate the challenges of the 21st century. As we wrap up this deep dive, let's remember the lessons we've learned from Professor Ghosh.
Let's approach these issues with nuance and curiosity,
Striving for progress while also being mindful of the responsibilities that come with it.
because the choices we make today will shape the energy landscape of tomorrow.
So keep questioning, keep exploring, and keep pushing for a brighter, more sustainable future.
Absolutely.